All right, hello everyone. Today I am here with Lewis Lynch. My name is Philip Zacchio, and today we are going to be presenting our project, malware detection and machine learning. So with that out of the way, I'm going to hand it over to Lewis.
Okay, hello, I'm Lewis, and I'll be presenting the first portion of our presentation. So we'll look here at the first slide, and I'm going to be briefly going over malware detection in general. So basically, the overall purpose behind malware detection is having the capability of successfully detecting malware on a given system. And dynamic analysis and static analysis are the two types of analysis pertaining to malware detection. And implementing machine learning methods onto malware detection, as these techniques have proved to be effective against malware, but they have also resulted in high false positive rates for detecting malware. Okay, and so for slide 2, I'm going to discuss malware samples. Malware samples are often sought after by researchers to investigate potential threat mechanisms and to avoid attacks by inventing more vigorous forms of defense. And there are a great many freely available sources on the web for acquiring malware samples. They can also be easily obtained from malicious URLs. And a statistic from a little over a year ago that was published on the site 24 Security Statistics That Matter in 2019, stating of all the recognized attacks, 44% involved banking, payment systems, online shoppings, and other closely related industry sectors. Okay, and for slide 3, we'll be looking at a few of the popular malware delivery methods. Utilizing a technique for spamming emails is one of the most popular ways to deliver malware. And oftentimes, attackers can gain the upper hand by tricking users into getting them to unwittingly open up emails and then unload a malicious payload by clicking on a link on an attachment, and they can have provided with their destructive emails. And not too surprisingly, a tremendously popular method for distributing malware these days is using strategies involving social engineering tactics. Okay, and for slide number 4, I'm briefly going to discuss the importance of using data sets. Because it's imperative to choose a high quality data set. It will be required for the effectiveness for the methods that are performed using the wide range of data mining approaches. And another important factor is being able to secure a data set with a large enough sample size that is going to provide for sufficient analysis of the data mining's overall performance. And lastly, in order to choose a data set that we felt would be the most beneficial for our malware project, Philip and I spent a great deal of time and effort looking for a data set that would produce superior performance results. And for slide number 5, I'm going to briefly go over this table of 5 important factors that compromise cleaning a data set. But of course, for our data sets, we defined a Google Colab model that we use Python for pre-processing the data programmatically. But first, you need to try to remove any duplicate or insignificant observations from the data set. In the second step, any structure-related errors within the data set will need to be corrected. For the third step, any problematic outliers should be filtered or eradicated from the data set. In the fourth step, missing data will have to be handled in a beneficial manner that you deem to be the most appropriate. And finally, in the last step, you should attempt to validate and ask yourself questions internally about the entire data cleaning process from start to finish. Okay, and for slide number 6, as alluded to in a previous slide, after in-depth search to locate the best data set for our machine learning project, we mutually agreed on the following data set here. It's benign and malicious PE files. It was created in 2018, and we were able to discover it on the Kaggle data scientist website. And we felt that this one met all the qualifications we needed to create our final project for this class. Okay, and now for the last slide, number 7 here, I'll quickly go over this block diagram we developed for the different phases of examining the data. So first you'll load the data, and this will give you a good visualization for the next phase. And next you're going to choose a dependent variable, and then you can run your model, and then you'll check for accuracy, tune the model, and next you'll run the model again. And last and most critical step is that you effectively analyze and accurately interpret the final output. So Well, this wraps it up for my part of the presentation, and now I'm going to turn things over to Philip for the second portion of our presentation, and he's going to be discussing all the algorithms we utilize during our project.
Thank you, Lewis. As you said, I will be just going in depth about some of the algorithms that we used when developing our project. These were the four main algorithms that we used, as you can see: logistic regression, decision trees, random forest, and naive Bayes. I will start off here with logistic regression. So what logistic regression is, it's basically used to measure like binary items. So whether that's yes or no, or right or wrong, or basically one or two, so two separate things. As you can see by the picture on the slide here, you're basically drawing this wave-shaped line through your data set graph and separating basically your two sectors of your graph, yes or no, like I said, right or wrong. In our case, we looked at using logistic regression to determine whether data is or is not malware. And then we felt also that this algorithm worked well with a couple of other algorithms that we used in this project, such as the decision tree. The decision tree is used for, again, classification of data. Like I said, it does work in a sequence with logistic regression. So for example, after the data is sent through, you have, for example, a piece of data. It goes through logistic regression. Yes or is it malware? Yes or no? If it is, then determine that it is in fact malware. It'll go through a decision tree here, and that will then basically determine the type of malware, as you can see from the fourth comment. So the picture in the slide, you basically, again, start off with your very first piece of data. If it's yes, you ask basically multiple questions. If it's yes, you go one way. If it's no, you branch off into another way. And then it'll basically split off into different groups. So the third algorithm that we used basically, again, grows off of decision trees, and that is the random forest algorithm. So the random forest algorithm consists of multiple decision trees. Basically, it's a bunch of decision trees that are grouped into one group. As you can, like I just said, it's used to group multiple categories of data, i.e. multiple decision trees. Compared to the decision tree, it provides a more stable and accurate prediction for your data. And like I said, the example that we would use in our specific project would be that it would group different types of malware together. So basically, you would have data, again, just to recap, going through logistic regression. You would then split it off into a decision tree to determine what type of malware it is. So you would then have, for example, a malware decision tree for spyware, for ransomware, etc. You would then group all of those decision trees of different malware into one big group, and that would produce this random forest. And then finally, you have naive Bayes. This algorithm, as you can see by the formula in the picture, predicts different variables of data based on data attributes. One major benefit for naive Bayes is that it makes these predictions extremely fast. That works well, especially for our data set, because I think we had around 19,000 entries within our data set, so it is able to make those predictions very fast as to whether it is or is not malware. And I also thought that this is a great algorithm to use for real-world cybersecurity tools. I know from my experience, whether it's at my job or a previous class, I've used cybersecurity tools such as, I know Lewis mentioned, like spam emails were one of the biggest ways that people are getting malware on their devices. Naive Bayes would basically say, hey, it'd be used in these malware detection tools so that it can say, hey, I'm recognizing that this is malware. Don't click on this link or don't click on this attachment. And so it's able to recognize that within a split second. And, it's obviously sometimes it's going to be wrong, sometimes it's right. And the really can't have 100% accuracy with machine learning. But yeah, so that is about wraps up the algorithms that we used within our project. This brings us to the final slide. Really quickly before we end, I just want to come over here and pull up our basically our Colab that has all of our code in it, just to skim through very quickly. So you can, as you can see, there's here's our data pre-processing. Let me see our data pre-processing code. Let me see. Here's a chart that we have generated after running all of the code in here. And then down here, here's the different sections for building the different algorithms that I had discussed about. So here's decision tree, building the decision tree model, and then we are testing. Same thing with the random forest model, building out the algorithm and then testing it. And then naive Bayes, again, calling the method and then testing it out. And then the logistic regression. And then further down, we're dividing it into dependent and independent variables. Then here's more of the building of the naive Bayes, random forest, and logistic regression models. So let me see. Lewis, do you have anything else to add, or have we pretty
No, I
much
think
covered it?
you got everything covered there. Great job, Philip. That's pretty much it for me.
Awesome. Well, thank you everybody for tuning in and listening, and yeah, thank you for your time.
Thanks.